learning about composite functions today, so it's important to remember what this notation is. When you have that f with that little open circle g, this really means f of g of x. Sometimes you can read it as f composed with g. You'll hear me usually just say f of g of x or f composite g, one over the other. So they all mean the same thing. The idea that you guys need to get from this is this notation means this second function here, we are plugging the whole function into the first function. So you're putting a function in a function. Now generally we like to put a number in a function. So we're like, oh, f of 1. So I'm going to take 1, plug it in for x and solve. Now we're taking a whole function, not just a number. So to evaluate these functions, f of g of 1, I'm going to show you on the first one. I'm going to go a little bit longer and then we'll do the short way on the rest. But what this is saying, it's saying we're going to do f of g of x. Okay, and g of x is like my new x. So what I'm going to do, I'm going to take my function f, and that's 2. I'm going to put a parentheses where the x is and square it minus 3. So this is f of x right here. All right, but in f of x, I'm going to be plugging in g of x. Well, what is g of x? It's 4x. So what I'm doing is I'm plugging in g of x, what g of x is, and this becomes 2 times 16x squared. Remember, anytime you square a product, you have to square each part, minus 3. So this is 32x squared minus 3. This is f of g of x, but they want us to evaluate f of g of 1. So what we're going to do is we're going to replace this x with 1. So then we have 32 times 1 squared minus 3, and our final answer here is 29. Okay. Now this is the long way to do it. So on the rest of them, I'm going to show you the short way. So if I am given the number that we are evaluating, I would not put in the whole function this way. We are going to need to do this later on in today's lesson, so I wanted to show that to you. But if you have this number value, what you really want to do is evaluate. In this case, g starts first, and so instead of f of x, we're going to say f of 1. So we are trying to figure out what f of 1 is and plug that into g. So easiest way is evaluate the inside. So f of 1 is 2 times 1 squared minus 3, and what is that? Negative 1. All right. Does everybody see this? F of 1 is negative 1. Everybody good? Well, if that's the case, then really I'm just trying to evaluate g of negative 1. And what is 4 times negative 1? Negative 4. Done. Okay. All right, everybody do C and D. When you're done with C, go ahead and look up. All right, check D. Any questions so far? Okay, I want you guys to take a look at A and B here. All right, so we're going to look at our answers for A and B. We have composite functions here, f of g of 1 and g of f of 1. And the question is, are they commutative? Why not? Commutative means that if you switch it around, it's going to equal the same thing. So, for example, addition is commutative. 2 plus 3 equals 3 plus 2. They equal the same thing. But here, if we flip-flop, that's not the same thing. So for this guy right here, we are going to say no. And then we can see that f of g of 1 is not equal to g of f of 1.